Now that we have the JSON with the weather data, we need to get the data out of the JSON and into a Java object to make it usable. Since we are following the MVC design pattern, data management and manipulation is the job of the model. All this data management and manipulation logic will be handled inside the weather data model class. Our goal is to make a weather data model object and store all the weather related stuff in there. So let's open the weather data model.java file that we included in the project stub. See if you can declare the 4 member variables that will hold our weather data. There needs to be a variable called mTemperature of type string, a variable called mCondition of type int, a variable called mCity of type string, and a variable called mIconName of type string. I'll give you a few seconds to pause the video. And here's the solution. To keep with good coding conventions, all these 4 variables should be labeled private. Next, let's create a method where we can do all the work related to extracting the weather data from the JSON and putting that data into a Java object. We're going to write a static method called FromJSON that returns a weather data model. This weather data model object will be the one that manages all the weather data. Android Studio is complaining because we promised to return a weather data model, but we have not done so in the FromJSON method. Let's change that now and create a weather data model object called weather data. And at the end of the method, let's add a return statement where we return that weather data object. Now it's time to tackle the JSON. First, let's store the city name in the mCity member variable. This is done by accessing the data from the JSON object via a key. Because it's not that easy to remember all the keys off the bat, it's handy to have the weather JSON hierarchy displayed on a website like jsonmate.com. Here we can see that for the latitude and longitude that I provided, the city name is Mountain View. And this piece of data is stored under a key called name. Back in Android Studio, I can access that value of Mountain View by typing jsonobject.getString and then supplying the name of the key, which is name. However, Android Studio is complaining again. The reason this time is that there's an unhandled exception. What does that mean? Well, it turns out that unpacking JSONs is risky business. We might encounter an error or exception. To be specific, the kind of error we might encounter is a JSON exception. A JSON exception can occur if OpenWeatherMap sends us a malformed JSON or if the JSON contains unsupported numeric values, like nans, not a number, or infinities. In Java, we have to be prepared for certain errors. In other words, we have to catch exceptions in situations where they can occur. To do that, we surround the JSON parsing code with a trycatch block, which will make Android Studio happy again. So a JSON exception is thrown when there's a problem processing this JSON. And as programmers, we're expected to handle this exception. Handling exceptions usually means giving the app a way of coping with failure. In this case, we will simply print the error to the logcat for simplicity. However, a more sophisticated approach would be to try and recover from the error or prompt the user to make a decision. As you're developing more Android apps, you'll be seeing that exceptions can occur in other situations too. For example, if we were trying to write or read to a file, we'd also have to surround that bit of code with a try-catch block, since files are often moved or cannot be found. Now, to continue parsing this JSON, we'll first have to talk about how OpenWeatherMap classifies the kind of weather. It turns out that OpenWeatherMap has a number of predefined weather codes to identify the type of weather. So every kind of weather is actually assigned a number, and each number corresponds to a specific weather condition. So the number 200 is thunderstorm with light rain, and number 202 is thunderstorm with heavy rain. You can check out the full list of these conditions on openweathermap.org/weather conditions. So personally, I tend to see a lot of 301 codes here in London. If we look at the JSON that we got back from the OpenWeatherMap API again, then we can see that the weather code for the condition is nested under weather, then 0, and then ID. So we have to get hold of the object under index 0 and then get the value for the key called ID. So let's add this code to the try block and extract the numerical value for the weather condition. So set the weather data's mCondition variable equal to the following: JSONObject.getJSONArray weather dot getJSONObject 0 dot getInt ID. And this is because our ID is nested inside an object named 0, which is nested inside an array called weather. We included a bunch of commented out code in the project stub to help match the weather codes from OpenWeatherMap to the file name of an icon in our drawable folder. Select all the lines of the update weather icon method and uncomment them under code, comment with line comment. So looking at the first if statement in this method, we're passing in a condition code and then checking to see if that condition code falls between 0 and 300. If it does, we have a thunderstorm, and our update weather icon returns the string tstorm1. We can then use this tstorm1 string to find the image with the corresponding file name in the drawable directory and display it to the user. If the condition is not between 0 and 300, the if statement goes on to check for other weather conditions. As a challenge, see if you can call update weather icon in the try block to set the correct value for mIcon name. I'll give you a few seconds to pause the video. And here's the solution. We're calling the update weather icon method and passing in the condition that we've extracted from the JSON. Now all we have to do is get the temperature. Again, we must first extract this data from the JSON. Looking at the OpenWeatherMap documentation, we learned that the temperature by default is reported in Kelvin, the base unit of temperature. This also explains why the temperature value of 284 in the JSON looked so strange, so it looks like we'll have to do some math in our Java code. But first we'll be extracting this value under a key called temp in an object called main. Since we're going to be doing a little bit of math, let's create a variable called tempResult that will hold the Kelvin value from the JSON. To convert that Kelvin value to Celsius, we'll subtract 273.15. Our American friends who really love their Fahrenheit will have to do some additional math and modify this line of code to read the following. But the rest of us probably want to stick with Celsius. Having done the conversion to Celsius and stored the result in a decimal number or double, we need to convert the tempResult value to a whole number, because nobody really cares if the temperature is 10 or 10.5 degrees. To convert to a whole number or integer, we'll use the math.rint function to round the temperature in tempResult to the nearest whole number, and then we cast this rounded value to an integer and store it in a variable called rounded value. However, since we eventually want to feed this temperature value to a text view on screen, what we actually want is a string. To convert the rounded value to a piece of text, we simply write integer.toString and feed it the rounded value. Now we're almost done. All we need to do is a way of accessing the private variables of mTemperature, mCity, and mIcon name. For this, we'll use Android Studio to generate some getter methods. Right-click below the last two and select Generate. Highlight the mTemperature, mCity, and mIcon name, but don't select mCondition and click OK. Inside the getter method for the temperature, append a degree symbol. Now you won't find the symbol on your keyboard, and you probably don't know the shortcut in order to type it, so just copy and paste it from Google. Fantastic. Now we're in a position to parse the relevant data from OpenWeatherMap's JSON. Now as a challenge, can you create a weather data model object called weather data from the JSON that we are getting back from the OpenWeatherMap API call? This will be inside the networking code that we wrote earlier. I'll give you a few seconds to pause the video. And here's the solution. Inside onSuccess, create a weather data model object using the fromJSON method. Notice how this static method is taking the place of the constructor? We're creating a weather data model using fromJSON instead of writing new weather data model. This is a very handy way of passing that JSON that we got as a response and passing it to our model. That way, we can let the model class worry about how to create that Java object by parsing the JSON. In the next video, we'll update the UI and show the weather data to the user on screen. I'll see you there.